Could iron and air be the solution to energy storage? As renewables share in our electricity generation increases, we need to find a way to store this energy. Intermittency and variability are two major issues we need to solve, and long-duration grid storage is definitely needed. So, let's first see how iron-air batteries work. An iron-air battery is made out of an air-breathing cathode and an iron anode with a liquid electrolyte solution. You can think of the process as rusting and unrusting the iron. To discharge the battery, you let in oxygen. This then reacts with the liquid electrolyte solution to form hydroxides. Hydroxides then oxidize and react with the iron, which leads to rusting. This process liberates electrons, which we can harness. So essentially, if the entire iron is rusted, your battery is depleted. To charge it, it's sort of the opposite. The electrons react with the iron to unrust it, which liberates the hydroxide and oxygen from the iron and leaves in the form of bubbles. So, why use iron-air batteries? Well, its main benefit is how cheap it is. Iron is a relatively cheap resource and air is basically free. Form Energy is developing iron-air batteries in the US and claims that the batteries would cost $20 per kilowatt hour. This is partly due to the iron-air having one of the lowest chemical costs, as you can see. Also, iron is an abundant resource. It being produced on every continent means there is less risk of having a single country monopolize production. Iron can also be recycled. Another benefit is that iron-air batteries are also safe, posing no risk of thermal runaway and low flammability. Finally, iron-air batteries have a high theoretical energy density. However, this is in theory. In practice, iron-air batteries reach around 1/8 of its theoretical energy density. This is quite a lot lower than lithium-ion, for example. The main issue, though, is the efficiency. Iron-air batteries average around 50% efficiency, putting it way behind other common battery technologies. I won't go into too much detail about why that is, but issues such as hydrogen evolution and passivation reduce the efficiency. You can check the description for more info. It is also limited when it comes to charging and life cycles, which limits its uses, but this is not as important for grid storage, for example. So, what could and should iron-air batteries be used for? Due to its size, weight, efficiency, and discharge rate, it is not really meant for uses such as cars. Therefore, its main use could be long-term energy storage. The issue with our current batteries is that it is too expensive to store electricity for long periods being more than 6 hours. Iron-air batteries could potentially be a great way to store energy cheaply for long durations. Form Energy, for example, claims that their batteries would provide 100 hours of energy storage. Thus, on those cloudy and still days where we could potentially face blackouts, iron-air could help with providing energy for a few days. I have been comparing iron-air with lithium-ion in this video, but in reality they should be seen more as a complement than a substitute. Lithium-ion could deal with intraday spikes, whilst iron-air, alongside other storage technologies, could help with multi-day storage. However, we are yet to see this technology in action, as the only company really currently with projects and contracts is Form Energy. They are backed by Breakthrough Energy Ventures, as well as other companies such as ArcelorMittal, an iron and steel company. Iron-air batteries aren't exactly a new technology, but haven't had much traction commercially in its first 50 years. So, the next few years could be very promising and interesting for iron-air batteries as projects start to commercialize. Will iron-air batteries have an important role in our energy grid in the future? Comment what you think. Thank you so much for watching. If you like this video and want to learn more about climate and energy, don't forget to subscribe.